Greetings to one and all. I am Jatin Saraf from C3 batch, roll number 180. My topic for research paper presentation is asynchronous replication in Microsoft SQL Server, PostgreSQL, and MySQL. Introduction. Replication is a set of technologies used for copying, distributing, and synchronizing data and objects from a database to another to maintain coherence. Database replication is known as a master-slave relationship between the original and the copies. Synchronization is usually achieved either by using a synchronous or asynchronous solution. Synchronous replication means that a transaction is finished when both master and slave finish the transaction with a commit or one with a rollback. Asynchronous replication is achieved when only the master has finished the transaction. The slave receives the modified data with a lag. Microsoft SQL Server is a relational database management system, commonly known as RDBMS, developed by Microsoft and FTS. Main purpose is to store and manage data types. This RDBMS also offers a wide variety of servicing for interacting with stored record such as search, query, reports, and data, integrity, and analysis as well. Microsoft SQL Server provides three types of replication: transactional replication, snapshot replication, and merge replication. Whereas PostgreSQL supports binary replication, also known as hot standby. Binary replication enables the users to replicate the entire database instance. It is not possible to replicate schemas, tables, or parts of tables as it is possible when implementing replication in Microsoft SQL Server or MySQL. In PostgreSQL, synchronization is asynchronous. What is asynchronous replication? For implementing and testing asynchronous replication for the already mentioned relational RDBMS, we will use a simple architecture with two servers. One server for the master and other server for the slave. Both servers will have the same hardware configuration. For Microsoft SQL Server, we have used a Windows 2012 64 server, and for a PostgreSQL and MySQL, we used Ubuntu 12.04 LST x64. Each RDBMS is configured to work on his own machine. For testing, we have created a database that can be used for a blog web application called BlogDB. In this database, we'll store information about articles that must have one author and can have many comments and tags. The relational design of the database has following tables: user table, articles table, comments table, tags table, link article tags. Merge replication in Microsoft SQL Server 2012. The first steps we took after installing and configuring Microsoft SQL Server 2012 on both servers were to create an operating system account that will be used to connect to the database using Windows authentication and to configure the database listeners on port 1433. This user will have the DBA owner role on the BlogDB database. After completing these steps from SQL Server Management Studio, we use the configure distribution wizard to set the master, whom in Microsoft terminology is known as publisher, on the first node and the slave, known as the subscriber, on the second node. By using merge replication, we can select what objects we be replicated. So we can distribute the entire database, or only some tables, or only some fields from a table. During this process, each table that is configured to be distributed will automatically be altered and gain a new column with a unique index on it known as rowget that can be populated during an JSON or update by using the database function new ID. Replication in MySQL. After installing MySQL 5531 on Ubuntu operating system, first step was to create on the master server account with replication privileges by issuing the next DCL query. MySQL grant replication slave on identified by 1, 2, 3, 4, 5, 6. To synchronize the master with the slave, we need to flush the database from the master, copy it on the slave, and run it. We also needed to configure both database instances by identifying my.cnf file and changing the server ID parameter, assigning the values 1 for master and 2 for the slave. The last step is to tell the slave to wait for modification that will come from the master. This is done by setting on the slave the master's log name and position. So on the master, to get the log file name and position, we will issue the next command. MySQL show master status. On the slave, we will run the next command. MySQL change master to master host. This is the address. Master user equals to REPL master and then password, master log file name, and various other commands. After this configuration are finished, we start the slave and replication is set. These are the commands. In MySQL, it is possible to create multiple replication groups with a single database. Using multiple replication groups allow a database objects to be partitioned between different replication groups. Replication in PostgreSQL. PostgreSQL 9.1 server is available as a package in Ubuntu operating system. After the package is installed by using the console commands, the first step is to edit on both servers the phba.conf file and add trusted host known by IP. Then we will edit the PostgreSQL.conf file so that the server will listen to for connection port on port 5432. The next step is to create a database used with replication privileges on the master. These are the following. After this, we will again edit the Postgre configuration file and change under the replication entry the parameter for the maximum number of wall sender processes. We will also need to change 3 other parameters. The wall level is set to the hot standby, the number of checkpoint segments, and the wall keep segments. The last step that needs to be done on the master server is to edit again the pg hba.configuration file and configure the host as a replicator based on the machine IP. On the server, we will only need to change the value of 5 parameters in PostgreSQL.configuration file. Hot standby equals to on wall underscore level / hot standby max wall senders checkpoint segments and the wall keep estimates. Also, we need to create a recovery file in which we will add the master's credential. These are the credentials that we'll add. The last step is to make a backup of the master instance and the copy it on slave and restart both servers. Now we'll test asynchronous replication. To test how replication works on these servers, we have taken two-step approach. First, we tested the CRUD operations on a single instance of each RDBMS, and then we have tested synchronization time for the CRUD operations for all the replicated RDBMS. To achieve this, we have wrote store procedures in Transcat SQL for the Microsoft SQL Server 2012. PL/PG SQL for PostgreSQL, and in the procedure language that comes with the MySQL. We have done a series of CRUD tests. For each series, we have done between 30 to 40 tests. In the following tables, the graphics, we will compare the mean times needed for the select, insert, update, and delete operation for all the RDBMS. All times are presented in milliseconds. The select test have been done on a single instance because this operation is not affected by replication. These are the various graphs that we receive after the test. Conclusion. Microsoft merged replication strength is that both the master and the slave can achieve read-write queries. Also, in Microsoft SQL Server 2012, you can replicate only parts of the database. This is not possible in PostgreSQL and MySQL. Microsoft Replication Solution also provides server independence. Servers from different locations can work independently with local data until synchronization is done. The fact that at the time of replication, a new column is added to every distributed table expands the space needed for storage to synchronize an out of sync server. The administration only needs to use the synchronization tool that is found in SQL Server Management Studio. PostgreSQL solutions for replication is a master-slave architecture. On the master, we can do read operations and slave only permits read operation. This approach is very useful for applications that run extensively read operations and data. MySQL replication solution is very similar to one proposed by PostgreSQL. The slave is for read-intensive operation and master for the CRUD operation. Synchronization of a new server is done by copying a data dump from the master to the server, then executing the data dump on the slave and finally resetting the server and changing the master log and master log position. We can obtain higher performance in MySQL application if we use query cache enabled and we have set the query cache size variable to a value greater than 40 kilobytes. The best mean times are given by PostgreSQL RDBMS. Microsoft SQL Server 2012 replication approach gives DBAs and developers a lot of flexibility when working with a database. Best feature is that in an organization with different departments, each office can work on a slave that has only the tables needed for that department, and the master can work as a backup for the entire database. All these tests are highly dependent on hardware architecture, especially on the RAM and CPU. A higher amount of memory directly impacts the number of records that are stored by the database management systems in the memory. The number of cores on the CPU influences the speed of processing queries. Various reference links that I have used to make this PPT. Thank you one and all for listening to my presentation.